We had a request from 2.5b. Do you mind shutting that door for me, please? For 2.5b, we had a request on number 23. The instructions say, I'll read it directly. I paraphrased them here. State how many complex and real zeros the function has. So we should know just by looking at this that it has 3 zeros. It doesn't ask us to find what they are. It just says how many of each type there are. If there are 3 zeros, is it possible for all 3 of them to be complex? No. Is it possible for 2 of them to be complex? Yeah. Is it possible for only 1 to be complex? No. The complex zeros have to come in pairs. So it's either there's no complex or there's 2 complex, but there's definitely at least one that's real. So I'm going to go ahead and say this one's real right now. How will I know? What's one way I could tell whether these other 2 zeros were complex? What would be an easy way to do that? You could graph it. You could put it in a graphing calculator and look at it. If they're real zeros, what are we going to see on the graph? We'll see x-intercepts. We know for a fact there's going to be 1 x-intercept. If there's only 1, that means the other 2 zeros are complex. If I see 2 other x-intercepts, then those are going to be real as well. So I'll leave that part to you. Just graph it in your calculator. See what it looks like. If you get a situation where it looks like this, that means there's 3 real zeros. If, on the other hand, you get a situation where it looks like this, there's only 1 real zero. That's this one here. The other 2 must be complex. Okay, what other questions did you have from, and again, this one didn't require us to find the zeros. They just wanted to know how many there are. Other questions from the assignments? Going once, twice. All right, we're moving on.